All right, welcome back. Today we're going to look at a stratified cubical seed triple and its dimensional tower. So for the setup, let X be a smooth, open, geodesically convex n-manifold whose closure has the combinatorics of a regular n-cube. Keep in mind the following, where V is a finite subset of the boundary of X. These are vertices of the cubical boundary, and define the corresponding closed block by X union partial X. So a foliational completion of the block B is obtained by attaching or selecting codimension 1 foliations whose leaves accumulate at specified vertices of the boundary. For a pair of vertices, let F sub ij denote codimension 1 foliation whose leaves accumulate at the two boundary vertices V sub I, V sub j. So for a leaf L in F, we require the closure of the leaf intersecting with the boundary of X to be these two vertices, this vertex pair on the boundary. So each leaf has two distinguished ideal endpoints, namely the vertices V sub I, V sub j. Vertex distances in the n-cube. In the n-cubical case, the possible distances between vertices are 1 square root of 2 up to square root of n. The largest possible vertex distance is the long diagonal distance. The supremum of the distances over the vertex pairs equals square root of n. So we restrict attention to the antipodal pairs of vertices of the n-cube. Since the n-cube has 2 to the n vertices, it has exactly 2 to the n minus 1 antipodal vertex pairs. Let A sub n denote the set of antipodal vertex pairs. For each antipodal pair, A is an element of A sub n. Consider a codimension 1 foliation, F sub A, whose leaves are mutually diffeomorphic to the model class L sub n. So each leaf is topologically an open cylinder dimension n minus 1, with its two ends accumulating at a pair of antipodal vertices of the cube. So among the leaves of each foliation, F sub A, select a distinguished leaf, which is volume maximizing inside the cubical block and satisfies the appropriate constant positive curvature condition. Denote this rigidified leaf by sigma sub A. After completion at its two ideal points, sigma may be viewed as a topological n-1 sphere with two distinguished cone points. For n equals 3, these are spindle or football surfaces. Since there are 2 to the n-1 antipodal vertex pairs, this produces exactly 2 to the n-1 distinguished rigidified sheets. Define the n-dimensional seed object by I sub n, defined to be the union of these sigma surfaces. So the interaction locus. The singular or interaction locus is the subset of I sub n where two or more sheets meet. We'll define it as the pairwise intersections, the union of the pairwise intersections where beta is not equal to gamma, and it's a subset of I sub n. This is just where the surfaces intersect. That's intersection locus. So gamma sub n carries a natural stratification by sheet multiplicity. For each k greater than or equal to 2, one may define the k-fold interaction stratum by a point in I sub n where P lies on exactly k distinct sheets. When n equals 3, the sheets sigma sub beta are two-dimensional, so their pairwise intersections are generically one-dimensional. In that case, gamma sub 3 is a seam graph. For n greater than 3, however, the pairwise intersections are generically n-2 dimensional. So gamma sub n should be regarded as a seam complex, or interaction complex, rather than merely a graph. The symmetry group pi sub n. Finally, denote pi sub n, the finite group of stratum preserving symmetries acting on the pair. The full cubical symmetry group is the hyperoctahedral group. And this group acts naturally on the vertices of the n cube and hence on the set of antipodal pairs A sub n. The actual symmetry group of the rigidified stratified object may be a proper subgroup of B sub n, depending on if we use global or piecewise isometries, which will have preserved the selected sheets and their incidence. So one may define pi sub n, defined to be the automorphism group of the stratum preserving of the pair, I sub n, gamma sub n. If one wants to retain only symmetries induced from the cubical block, we define pi sub n like that. And the stratified cubical seed triple. In dimension n, the construction produces a stratified cubical seed triple, where I sub n is the union of 2 to the n-1 rigidified antipodal sheets, gamma is the higher dimensional interaction complex, and pi is the finite symmetry group of stratum preserving symmetries. We'll look at the case n equals 3 now. For n equals 3, this recovers the concrete seed, where I sub 3 is the union of 4 maximally inflated constant curvature football surfaces. Gamma sub 3 is their seam graph, and pi sub 3 is the corresponding finite symmetry group. So now let's pose a question. The preceding construction produces, for each finite dimension n greater than or equal to 3, a cubical seed triple, where I sub n is assembled from the 2 to the n-1 antipodal rigidified sheets of the n cube. Gamma is the corresponding sheet interaction complex, and pi is the finite symmetry group of stratum preserving symmetries. One might naturally ask, is there a limiting object? Is there a natural limiting object in which we take n to infinity of the triple, obtained from the tower of finite dimensional cubical seeds? So we get this postulated or hypothesized tower of objects for each n dimension. And can the finite seed triples be organized into a compatible system of stratified spaces with symmetry? So that one may define through inverse limit or direct limit or some other construction. If such a limit exists, what geometric, combinatorial, and spectral information is retained by the infinite seed triple? Does gamma sub infinity become a universal interaction complex encoding the stable incidence, holonomy, symmetry, and spectral data of all finite dimensional cubical seeds?
Got me in my bag, big money rolling. French cuff my wrist, so the timepiece keeps showing. Cross-lace my sneakers, and my socks name brand. Glue on my soles, cause I'm sticking to the game plan. Got me in my bag, big money rolling. French cuff my wrist, so the timepiece keeps showing. Cross-lace my sneakers, and my socks name brand. Glue on my soles, cause I'm sticking to the game plan.